Hello everyone. Let's continue the chapter permutations and combination. So in our previous two classes, what we learned was the basic concepts about individual options. Once finding the individual options, how can we add, how can we multiply, and all those things. What we will learn today are the basic necessities and prerequisites to solve. No concept, formula. It's like Bodmer's rule. There's a technique through which we will later on use while using the formulas of permutations and combination. So we are going to learn factorial notation. We are going to learn factorial notation. Now, there are two symbols for factorial notation, and the concept is valid only for natural numbers. As such, the entire permutation combination chapter is valid only for natural number. Rather, I can say it's whole number, but they always say that it's valid for natural number, and there is an exception that we can also include zero. So, roughly or practically, if I say if you are including zero in natural, it becomes whole now. But they tell that it is applicable only on natural numbers, but we do also have zero. Okay, so it is only expressed for natural numbers. So the symbol is factorial n. This is how we write it, or we can also use an exclamation mark. What does this do? Let me first explain you with the help of an example. Factorial 5. This means that from 5, if 5 is a natural number, from 5, keep on reducing the numbers till you get 1. So basically what I want is I want to multiply all natural numbers from 5 till 1, reducing order. So I'll first write whatever factorial I have, I'll start from that. So 5 factorial, first 5 will come. Then reducing it by 1, 4. Because in natural number, what is n plus 1, n plus 2, we keep on adding 1, right? 5, 5 plus 1, 6, 6 plus 1, 7, 7 plus 1, 8. This is how we get all the natural numbers. So here I want to reduce it. So again, I'll reduce it by 1. So first natural number 5, then 5 minus 1, 4, then 4 minus 1, 3, and so on. So this is how we write. So I'll reduce it till I get the last portion, that is 1. This product is known as factorial 5, which is 120. So now understand, if I would have kept 5 with me, I would have got 4, 3, 2, 1. 4 into 3 into 2 into 1 can be written as 4 factorial, right? It can
Yes.
be written as 4 factorial. 4 factorial means what? From 1, 4 till 1. I can also do what? I'll keep 5 and 4. 3 to 1 can be written as
3 factorial.
3 factorial, depending on what I want, right? So if I have said 10 factorial, what does 10 factorial originally mean? From 10, multiply all natural numbers till 1. So I'll start from 10, then 9, then 8, till I get 1. So there are 10 numbers. What I can do is I can keep 10 with me. What's the next number? 9. So after that, I'll get all the natural numbers till 1. So from 9 to 1, I can write 9 factorial. I could have also done is I would have kept 10 and 9 both. I would have got 8 factorial. I could have also kept 10, 9, 8, and I would have got 7 factorial. Yes or no? So n factorial. Can you tell me what will be the answer? Open n factorial. The first will be n itself. If I'm opening factorial 10, the first number that I get is 10. Then I keep on reducing 1 till I get 1. So first number is n factorial. So n. The next number will be,
N minus 1. N minus
the next will be,
N minus 2. Minus 2
till
N
I get
minus.
minus 3, so on to 1.
till 1. 2 into 1. The last ending sequence will be what? 3 into 2 into 1. This is how it ends always. See? 3 into 2 into 1. Here also 3 into 2 into 1. Every sequence will end in that way. Yes or no? So when I said factorial 5, I got 5 factors. 5, 4, 3, 2, 1. When I opened factorial 10, I got 10 factors. When I opened factorial n, how many numbers are getting multiplied?
N
N
number
factors.
of factorials.
So again, this factorial n, how can I write it? I can keep n with me.
N factorial n minus 1.
N into n minus 1 factorial. I could have also done, I would have kept n minus 1 both, and then the number n minus 2, I could have written factorial, right? in any reducing order, whichever number you want. Why will I want? For example, if I have factorial 12 upon factorial 8, this is a simplification I want. So what I'll see is which is a larger factorial, 12, right? So I'll start opening 12 factorial till I get 8 factorial. So in 12 factorial, the first number that will come is 12. The next number
11,
11. The next number 10. The next number 9. The next number 8.
8.
So as
8,
soon as I can write 8 factorial because from 8 till 1, I'll get everyone divided by 8 factorial. It gets cancelled. Yes.
yes, ma'am.
Yes, ma'am.
So
Yes, ma'am.
11, 1, 1, 8, 8, 0. Everybody clear?
Yes, ma'am.
Yes, ma'am.
Now, what is the smallest value of n allowed here?
1.
1.
2.
Because it's a natural number, right? So, no. I can write factorial n as n into n minus 1 factorial. Do you all agree?
Yes, ma'am. Yes, ma'am.
And what is the smallest value of n that you said is allowed to be put here? N is a natural number. So the smallest value, the first value that I'm allowed is 1. So if I put here, putting n equal 1, we get factorial 1, 1 into 1 minus 1 factorial. What will be 1 factorial? 1.
1,
Now multiply only 1. And this is 0 factorial. So this is a formula. Remember this. So I said now we'll find values for every time using 0, but not directly. So every single time we find some reason to get 0. So as here, I have done nothing wrong. So using actually the definition and deriving a little, I can find the value of 0 factorial. Not exactly from the definition you can get it, but a little twist and turn helps you to find it. So we need to memorize that 0 factorial is 1. Also 1 factorial is 1. This is the only exception where these two values have the same answer. These two factorials have the same answer. Otherwise, no two factorial can have the same answer except them. If I'm saying that someone's factorial is 6, there can only be one answer. But someone's factorial is 1, there can be two different values. 0 factorial is also 1, 1 factorial is also 1. Am I clear?
yes, ma'am.
Second, while solving, since here we are talking about natural or whole, whatever the case, we are not allowed fractions, we are not allowed decimals, we are not allowed negative numbers, right? So here what we do is, whenever we are finding solutions, we can use a trick. Whenever we are finding solutions, we can use a trick. Okay, only because here we cannot have negative fraction decimal answers, only because of that. Otherwise, in a normal scenario, in a normal algebraic equations, we can't do that. So what am I saying is, suppose you have got n into n minus 1 equal 12. In a normal circumstance, what you will do? Multiply quadratic midterm. That's okay. I'm not saying it's not fine. It's not allowed. It's allowed. You'll get two answers. One of them will be negative or fraction. You'll ignore. Not possible. The other will be a natural number. You'll accept it. I'm also saying that there is one more way to do that. How? If you notice on the left hand side, there are two consecutive numbers, n and n minus 1. So 12 can be written in many ways. 1 into 6, 1 into 12, 2 into 6, 3 into 4, right? Even fractions. What I want is 12 to be written with the help of two consecutive natural numbers. Can I write 12 as a product of two consecutive natural numbers? How?
3 and 4.
3 and 4. I can write this as 3 into 4. Yes or no?
Yes, ma'am.
So on the left hand side, what is the larger number?
N.
In
N. And on the right hand side, what is the larger number?
4. 4.
So n will be 4. You can also compare the smaller one. On the left hand side, what is the smaller number?
N minus
And on the right hand side, what is the smaller number?
3.
So from here also I'm getting n equal to 4. You don't need to show both of them. It was just to explain you that no matter which one you compare, you'll always get the same answer. Okay? Everybody clear?
Yes, ma'am.
Yes, ma'am.
This also can be done for three numbers. Suppose you have got n minus 1, n minus 2, n minus 3 equal 1320. So cubic, we don't even know how to solve in general, right? We do trial and error. So here, since the left-hand side is a product of three consecutive numbers, n minus 1, then n minus 2, n minus 3, they are three consecutive numbers. So 1320 can also be expressed as a consecutive number, but we don't know how. So what we do is, we do the prime factorization. Okay. So I can divide this by 5, 264. I can divide this by 2, 132. I can divide this by 2, 66. I can divide this by 2, 33. I can divide this by 3, 11. So here, what is the largest prime number?
11.
11.
11. Right? So now you see near 11, either you'll be getting 10 or you will get 12. One of them will pakka get. Which one can you see? 5 into 2 will give you 10. Okay, I have 10. Do I have 12? Because if I have 10 and 11, I either need to have 9 or I need to have 12. 3 twos are 6 twos are 12. So 12. So I have the three consecutive numbers. So we always do prime factorization. The largest prime number always helps you to find. So now we compare. You can compare anyone. So the smallest on the left hand side.
N minus
Smallest.
minus
And minus 3. And on the right hand side, the smallest one is 10. So n will be what? 13. You can compare anyone, the middle ones, not positionally middle ones, actual value types middle one, or the largest numbers also, the smallest number in any which way. But largest number has to be compared with largest. Smallest one has to be compared with smallest. In case you have ever a doubt whether n minus 1 is smaller or n minus 2 or n minus 3, take n to be any rough value. Suppose if I would, in order to test, I would have taken n10. 9, 8, 7. So this gives me a clarification that, okay, n minus 1 is the largest one. So whenever you have a doubt about which one is largest, take any rough one. Okay, that will give you a clear idea about which one is smallest or which one is largest. Clear?
yes, ma'am. Yes, ma'am.
Everybody done? Also, what we can do here is, suppose factorial x equal factorial y, except 0 and 1. X and y are neither equal to 0 nor equal to 1. Except these two, because they have the same factorial. No? Except them, we can always tell that if two factorial values are same, then x will be equal to y. Then x will be equal to y. Why am I teaching you this? For example, factorial r equal to 6. Since on the left hand side it's factorial, we want to express 6 as factorial. What we do is, what is factorial? Serial order multiplication of natural numbers. So you need to have 1 in everyone. You need to have 2. You need to have 3. You cannot have 7 and 1. You need to have the in-between numbers, or the smaller ones, so you definitely need to have. So what we do is, we factorize, not necessarily prime factorization. We go in a serial order. 1, 2, 3, so that I get a sequence. So obviously 6 will be divided by 1, 2. I get 1, 2, 3. So which one is a larger? 3 into 2 into 1. So it is which factorial? 3 factorial. Because 3 factorial means what? 3 into 2 into 1. So what we do is, whenever I want to see whether this number is a factorial of someone, I start dividing it up in a serial order. First by 2, then by 3, then by 4. The larger one is your factorial. So now I can compare and say that, okay, R is, if I tell you that factorial r is 5040 or factorial r minus 1 is 5040, the first thing that you need is 5040 to be expressed as a factorial. So 5040 will definitely be divided by 1. Start from 2. Divide it by 2, then divide by 3, then divide by 4 till you get all of the numbers in a sequential order. Answer?
Mom, is it 8?
8.
No.
8.
Answer 8.
Um,
Okay, fine then. So 50402, then 3, 4, 5, 6. So 2, 3, 4, 5, 6, 7. It is 7 factorial. So comparing r minus 1 equals 7, r will be equal to 7. R will be equal to 7 plus 1, 8. Done?
yes, ma'am. Yes, ma'am.
Question. Express in factorial 5, 10, 15, 20. Express as a factorial. Express it in factorial. Okay, see. 5, these are all multiples of 5 in a consecutive format. 5 can be written as 5 into 1. 10 can be written as 5 into 2. 15 can be written as 5 into 3. 20 can be written as 5 into 4. Agree? So 5, 5, 5. This is 5 cube. Then you have 1 into 2 into 3 into 4 into 5, which is 5 factorial. So 125 into 5 factorial. Right? Is it
Ma'am, it's 5 power 4.
Yes,
It's
ma'am.
come as 5 power 4 into 4 factorial.
4 factor.
I write this? Even this is correct, I guess. I took one of the 5 from that and made it 5 factorial. You are telling me write this 5 power 4 into factorial 4, right? So if I take a 5 from here, 5 into 4 factorial is what? 5 factorial. I can write this. Isn't this a larger factorial?
Mm.
But if the numbers would have been 6666, then I could not have written. I would have written 4 factorial. Did you understand?
Yes, ma'am.
What will be happening here? 4 into 5 into 6 into 7. Express it as a factorial. See, 4, 5, 6, 7. These are already consecutive. The only thing that is stopping you from writing it as a factorial is the absence of 2 and 3. 1, I can write any which way. The only absence of 2 and 3. If 2 and 3 would have been added, it would have been multiplied, then I would have written it as 7 factorial. So what I'm going to do is I'm going to put 2 and 3 on my own. But can I do that? This is wrong. So to balance it, what will I do? Very good. I'll divide it by 1 into 2 into 3. Now this is balanced. 1, 2, 3, 1, 2, 3 gets cancelled. I'm still left with 4, 5, 6, 7. But now this has made me, this has helped me to write it as a factorial. So the numerator is from 1 to 7, which is 7 factorial. The denominator is 1, 2, 3, that is 3 factorial. Understood, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Find x if x by 6 factorial, 1 by 5 factorial, 1 by 4 factorial. Try. So what can be done? I'll take 6 factorial on the other end plus 6 factorial by 4 factorial. Here I'll open 6 till I get 5 factorial. I'll open 6 till I get 5 factorial. It gets cancelled. This gets cancelled. So this is 6 plus 30. That is 36. Yes.
Yes, ma'am.
Yes, ma'am.
So when you'll be doing permutations and combinations, these are the simplifications that are going to be necessary. Is it okay? Everybody understood?
Yes, ma'am.
Yes, ma'am.
Emil Agarwal, exercise 7.1. Question number 1. Factorial 3 into factorial 5. Factorial 3 is 3 into 2 into 1, 6. Factorial 5, 5 to 1, 120. Answer is 720. Yes?
Yes, ma'am.
Question number 2. Factorial 88 upon 86. So we open the larger factorial till we get 86. So 88 into 87. Factorial 86. Answer 7656. Does it match?
Yes, ma'am.
Yes, ma'am.
Third. Factorial 12, factorial 10, factorial 2. So I'll open factorial 12 till I get 10. So 12 into 11, factorial 10. Factorial 2 is 2 into 1. Answer 66.
Yes, ma'am.
Yes, ma'am.
Fourth one. Factorial 9 minus factorial 8 upon factorial 7. 9 into factorial 8 minus factorial 8 factorial 7. Taking factorial 8 common. Opening factorial 8 till I get factorial 7. Answer 64. You may have done in a different manner, but the answer should be 6. Got the answer?
Yes, ma'am.
Yes, ma'am.
Factorial n plus 2 upon factorial n plus 1. So the larger one is n plus 2. N plus 2, then n plus 2 minus 1, n plus 1 gets cancelled. So n plus 2. Question number 2. N is 6, R is 2. What we want to find is factorial n upon n minus r factorial. So 6 factorial, 6 minus 2, 4 factorial. So 6 into 5 into 4 factorial. 5 6 are 30. Done?
Yes, ma'am.
Number 2. N is 10 and R is 4. So factorial n minus 4 will be 6. So 10, 9, 8, 7. Factorial 6. Answer
504.
5040. Yes?
Ma'am.
Any doubt till here?
No, ma'am.
Question number 3. N is 5, R is 2. Factorial n, factorial r, and n minus r factorial. N factorial, factorial 5. Factorial r is 2. Factorial n minus r is 3. So opening 5 factorial till I get 3 gets cancelled. Answer is 10.
Yes, ma'am.
Question number 2. N is 15 and R is 12. So factorial n, factorial r, n minus r. Opening 15 till I get 12. This is 6. Answer
455.
455. Any doubt?
No, ma'am.
Question number 4. 3 into 6 into 9 into 12 into 15 into 18. So earlier we did the sum with 5 stable. This is 3's multiples. So 3 can be written as 3 into 1. 6 can be written as 3 into 2. 9 can be written as 3 into 3. 12 can be written as 3 into 4. 15 can be written as 3 into 5. 18 can be written as 3 into 6. So it is 3 6 times. 2, 3,
Yes, ma'am.
4, 5, 6. And the remaining are 1 into 2 into 3 into 4 into 5 into 6, which is 6 factorial.
Yes, ma'am.
We never expand anyone except 2 for factorial for more than 5 power. We only open till 5. Anything to the power 5, we don't go beyond it unless it's 2. Second, it is from 6, 7 up to 12. So again, this similar sum we did is already there from 6 to 12. What is missing is 1 to 5. So here we can add 1, 2, 3, 4, 5. And from 6 to 12, we already had. So matching it up, dividing by 1 to 5. So the numerator becomes factorial 12. The denominator becomes factorial 5. Clear?
Yes,
Ma'am.
Any doubt?
No, ma'am.
अगर कोई एकदम सुंदर से टेबल चल रहा है, जैसे वो 3 का टेबल चल रहा था, तो ऊपर वाला है, और वो सीरियल ऑर्डर में नहीं था, ये वाला सीरियल ऑर्डर में। Question number 5, equations. N plus 1 factorial is 20, n minus 1 factorial. So we open the larger factorial. So we'll open n plus 1. So n plus 1 is the first one. Second will be n plus 1 minus 1, that is n. Next will be minus 1. So n minus 1. If it is factorial 10, we write 10. Then 10 minus 1, 9. 9 minus 1, 8, and so on. So here n plus 1 factorial, then minus 1 n, again minus 1 n minus 1. Sorry, gets cancelled. Here I have two consecutive numbers, and 20 can also be written as
5 into 4 or 4 into 5?
n 5 into 4 or
4 into 5.
okay. So left hand side the smaller number n, the right hand side the smaller number 4. Second, 1 upon 5 factorial plus 1 upon 6 factorial equal n upon 6 factorial. So bringing the 6 factorial from the right hand side to here, 6 factorial by 5 factorial, 6 factorial by 6 factorial. So this is 6 into 5 factorial, 1 equal n. Gets cancelled. Answer is 7.
Yes, ma'am.
Any doubts?
No, ma'am.
Third, similar. 1 upon 6 factorial plus 1 upon 7 factorial equal n by 8 factorial. So bringing 8 factorial here. So opening 8 factorial till I get 6 factorial. So 8 into 7, 6 factorial. 8 into 7 factorial. 6 factorial gets cancelled, 7 factorial gets cancelled. 56 plus 8. Answer is 64.
Yes, ma'am.
Fourth, factorial n upon n minus 2. Which one is larger, n or n minus 2? Factorial n. So we'll open n factorial till we get n minus 2 factorial. So n minus 1, n minus 1, minus 1, n minus 2. So on the left hand side, we have two consecutive numbers. So 110 can also be written as
11 into 10.
on the left hand side, the larger number is n. On the right hand side, the larger number is 11. Yes?
Yes, ma'am.
Then fifth one. Factorial n by 2 times n minus 2 factorial, and the ratio of n factorial factorial 4 n minus 4 is in the ratio 1 by 6. So from division to multiplication, it gets reversed, reciprocated.
Yes.
Factorial 4 n minus 4 factorial n. Factorial n gets cancelled. Factorial 4 is 24. 4 into 3 into 2 into 1. 2 12. Out of n minus 4 and n minus 2, which one is larger?
N minus 2.
Minus.
So we will open n minus 2 till we get n minus 4, n minus 2, n minus 3, n minus 4 factorial gets cancelled. 72. So the right hand side is a product of two consecutive numbers. So 72 can be written as
8 into 9.
8 into 9. Now comparing. So in the left hand side, which one is the larger number? 9. And in the right hand side, the larger number is?
In minutes.
So n will be 11.
Yes, ma'am.
Yes.
One second. My fault, I wrote the question wrong. Instead of 4, I wrote factorial 4. So this is wrong. It's okay, man. So this will be 4 by 2, that is 2. This becomes 12. So this will be 3 into 4. The larger number is 4. So n will be 6. If it would have been factorial 4, then the answer would have been 11. Okay. So same pattern, whatever comes in exam. Any problem?
No.
Question number 6. Prove that. I'll start from RHS. Factorial n and n plus 1. What I want to prove is n plus 2 into n factorial. So let me first express both of them in n factorial. N plus 1 factorial can be written as n plus 1 n factorial. Taking n factorial common, 1 plus n plus 1 factorial n into n plus 2, which is LHS. Is it okay?
Yes.
Everybody, is it okay, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Prove question number 7. Okay, let me show you. To prove question number 7, factorial n minus 1, n minus 2, n minus r plus 1. This is what we have to prove, right? So let me first show you with the help of an example. I can't prove with the help of an example, right? But let me first explain. If I have factorial 10 by factorial 6, I'm dividing 2 factorial, the numerator is larger. So I'll open 10 factorial till I get 6 and I'll cancel 6 factorial. So I have 10 into 9 into 8 into 7, then 6 factorial. So I'm left till 10, 9, 8, 7. So whenever I'm dividing 2 factorial, the numerator is larger. So my answer will start from the numerator and it will end at a number just larger than the denominator. Because as soon as I get denominator, I'll cancel. So before denominator, it's just one step extra. If it would have been factorial 20 upon factorial 17, this will be 20, 19, 18, 17 factorial. Gets cancelled. So when I saw that I need to divide 20 factorial and 17 factorial, I got to know that I need to start opening from 20 and I'll stop at a number just more than 17. So I'll stop at 18 because 17 gets cancelled. So directly, can't you tell me factorial 52 upon factorial 48? I'll start opening the larger one, that is 52, and I'll stop at 48 gets cancelled. So what will be left is
52,
52
51, 50, 14.
15,
till
14.
49 because 48 gets cancelled. So just a number larger. Hana. So now if I'm opening RHS, be careful. So I'll open the larger factorial till I get the smaller one. So if the denominator would have been factorial 10, I would have opened till 11 and then I would have written factorial 10, which will get cancelled. If my denominator would have been factorial 20, Then I would have opened till factorial. I would have opened till 21, then 20 factorial. 20 factorial would have been cancelled and I would have been left till 21. So here I'll open n factorial, n, n minus 1, n minus 2. Till the time I get n minus r factorial, it's a smaller number, right? So it will definitely come in between. It will get cancelled. What is the number just before n minus r? If it would have been factorial 10, I would have ended till 11. If it would have been factorial 20, I would have ended till 21. If it would have been factorial 49, I would have ended at 50. If it is n minus r, I'll end at a number greater.
Yes.
Yes or no, guys?
Yes.
No.
So I'm left with n minus 1, n minus r plus. Clear?
Yes.
No.
Any doubts?
No, ma'am.
No, ma'am. Okay. Now we'll do a very important and a very different sum. We'll just understand first, then I'll come to the main sum. Let me first explain you with the help of examples just like this. I'm gonna take the factorial of an even number. So even number 10, 12, 14, 6, 8, 20, 25, 26, 40, 50. Every even number is of the form class 10. Every even number is of the form 2 into something. If it is 10, 2 into 5. If it is 40, 2 into 20. If it is 10, 2 into 5. It is 12, 2 into 6. Every even number can be written as 2 into natural number. So I'm only talking about even numbers. If I have factorial 10, it's an even number. When I open the factorial, how many numbers I'll get? I'll get 10 factors starting
Yes.
from 10, 9, 8 up to 2 into 1. I'll have 10 factors. Any doubts in that?
No, ma'am.
No, ma'am. These 10 numbers, half of them are even and half of them are odd. Yes or no?
Yes.
Yes, ma'am.
How many even, how many odd?
Five even, five.
So I'll have 5 even factors. I'll have 5 odd factors. When I'm writing the even factors, it will start from the very same number 10. That
No.
8, minus 2, 6, minus 2, 4, minus 2, 2. The last one will be 2. And if I'm writing odd, 9, minus 2, 7, till I get 3 and 1. Right? Now, for the odd, I'm not saying anything. 1, 3, 5, 7, 9. Let it be. In whichever way you want to write. For the even, can I take common? No. Because in multiplication, you don't take common. You take common in plus and minus. So here, 10 can be written as 2 into 5. Like the multiples of 3 now we just did. 8 can be written as 2 into 4. 6 can be written as 2 into 3. 4 can be written as 2 into 2. 2 can be written as 2 into 1. How many 2's are there? 2 to the power 5. I'm left with 5, 4, 3, 2, 1, which can be written as,
5 factorial.
so 2 power 5, 5 factorial, and all the odd numbers. Yes? Yes?
Yes, ma'am.
If I would have had factorial 24, again it's an even number. If I open, how many numbers will I get?
For
24 numbers from 24, 23 up to 2 into 1. I'll get 24 factors. How many are even? How many are odd?
12 are even, 12 are odd.
12 even factors. 12 odd factors. Tell me the even factors. 24 is the first even number. Then 22, and I'll end up at 2. 4 into 2, the last ones will be. And here when I'm writing odd, it is 23, The last one will be 5, 3, 1. Any doubt?
No, ma'am.
If I want, I can write the odd numbers as 1, 3, 5 up to 23 because when you're multiplying, it doesn't matter. Now, in case of even, since it's multiplication, I can't take 2 common. But each of the number can be written as a product of 2. 24, 2 into 12, 22, 2 into 11, 4, 2 into 2, 2, 2 into 1. How many 2's will come?
12
Each
twos.
of the even number will give you
Power
1, 2. So I'll get 12 times. From 24, I took 1, 2 outside, 12. From 22, I took a 2 outside, 11. From 4, I took a 2 outside, 2. From 2, I took a 2 outside, 1, which can be written as
2 power 12 into 12 factorial into the
into
remaining
all
one.
the odd numbers.
Yes,
Can you
ma'am.
see a pattern?
Yes, ma'am.
So if it is factorial 50, when I open, how many numbers will come?
50 numbers.
From 50, 49 till 1, there will be 50 factors. How many even, how many odd?
25 are even, 25 are odd.
25 even, 25 odd. When I'm writing even, I'll start from 50, 48 till 4 into 2. When I'm starting odd, I'll start from 49 till I end up at 3, 1. From here, how many 2's will come? 2 power 25. So
Yes,
from 52 goes 25, 48 2 goes 24, 4 2 goes 2, 2 2 goes 1. And these are all the odd numbers. So this
yes.
can be written as 2 power 25 factorial 25. Any doubt?
No,
No,
ma'am.
ma'am.
So that means if I have factorial twice n, it is an even number.
Yes, ma'am.
When I open this factorial, how many factors will I get? If I open 10 factorial, I get 10. If I open 12 factorial, I get 12 factors. If I open 50 factorial, I got 50 factors. I'm opening twice n factorial, I'll get twice n factors. And what will I get as a factor? First, the number itself, then
Yes.
minus 1 till I get 1. In this, how many will be even, how many will be odd? Half of it. That is
N
n even factors and n
even
odd
factors,
factors.
n odd factors.
So in even, twice n will come first. The next even number will be
2
twice
and
n
minus
minus
2.
2. The last will be 4 and 2. When I'm writing even, it is 2 and minus 1. End up with 5, 3, 1. So in order, I'm just writing in this order. In even, from every number, a 2 will come outside. So there are n even numbers. So how many 2's will come outside? How many n's? How many 2's?
And 2.
2 power 2.
2 power n. I'm left with, from here 2 goes n. From here 2 goes n minus 1. From 4 2 goes 2. From 2 2 goes 1. So 2 to the power n factorial 1 3 twice n minus 1. Yes, this was
Yes,
the
ma'am.
question. It's your last example before 7.1. Prove that factorial 2n is 2 power n factorial 1 into 3 into twice n minus 1. The example just before exercise 7.1. Example 5. Example 5. Did you understand, guys?
Yes, ma'am.
Yes, ma'am.
That's it for today.